Okay, I think we can get started here. For the few that signed up just for the second presentation, quick introduction. Name's Rob Reese. I'm with TESCO, the Eastern Specialty Company. I reside in Indiana and cover the upper Midwest. Been to NREA in person a few times, and I am happy to present here on looking for dangerous installations and incorrect billing. Some of what we're going to touch on in the next hour or so is going to be similar in topic to the previous session, but more focused on dangerous, anything that can be considered dangerous or affect incorrect billing and revenue generation. We're going to look at the importance of why to keep this stuff in mind, and then I'm going to split it up. We're going to talk about dangerous installations first, and then switch to incorrect billing, and then I want to go over some useful tools and equipment available out there to keep you safe and keep the metering accurate. So just things to keep in mind and why we're having this session. Some notes that I pulled from some websites. 166 fatalities, electrical fatalities in 19, which was an increase of a few percentage points over 18. And it was the highest number since 2011. And in that year, I couldn't get numbers for the 2020. They weren't updated as of yet. So 19 was as recent as I could get. But in 19, 8% of all injuries were fatal. The next portion of this slide shows a breakdown of the percentages and the ages of the workers involved and the fatality situations. So, just be careful, we never, no one wants to, be injured, to be injured or even have a death associated with our workspace. Going forward, 30% of all electrical fatalities occurred at a private residence. 30% were industrial places, and public buildings accounted for 13%, street and highway 11%, and farm 6%. A quote from the late great George Carlin: "Electricity is organized lightning." This was meant as a joke, but not a joke in any way, shape, or form as you're working with electricity. Any voltage without current will not kill you. But any voltage with current can kill you. And just to show just how dangerous metering can be, here's some example pictures of explosions, fires at the meter installations. First and foremost, wear your PPE, personal protective equipment. Utilize the PPE that is set forth by your utilities procedures and processes. These can include leathers, rubber gloves, face shields, FR clothing, safety shoes, even blankets. Always wear your PPE. Your first line of defense keeping you safe at the job site and at the meter installation. Cannot express this enough. First and foremost, we always want to prohibit and never be a part of an arc flash incident. And I'm going to read this verbatim because it's very, very important and shows the magnitude and the severity of what we're dealing with here. An arc flash is sometimes used interchangeably with an arc fault. An arc flash is more accurately defined as the light produced during an arc fault. An arc fault is a type of electrical fault that results from the breakdown of an insulating medium between two conductors, where the energy is sufficient to sustain an arc across the insulator, often air, and can cause extreme amounts of light, the arc flash. Immense heat upwards of 19,000 degrees Celsius and a resulting explosive pressure wave or arc blast occur. These forces combine to create a hazardous condition that can vaporize metal, destroy equipment, and pose a significant hazard to anyone in the vicinity. I cannot express this deep enough. An arc flash is the last thing any of us want to be even close to. So along with your PPE, always follow your utilities, procedures and processes and safety rules. I can go over a list of things here at this presentation. You can hear other items elsewhere, but always follow your utilities, rules, regulations, and processes. Examples here, you're responsible for your safety and the safety of others. Wear your PPE. Always use equipment and tools safely and properly. Lift properly using your legs and not your back. Keep your work area clean. Wear appropriate and safe work clothing and footwear. Report any unsafe conditions. Clean up spills immediately. Report all injuries. And of course, no alcohol or drugs to be used or allowed on company property. This is just one example of a set of safety rules, but once again, use the rules applied by your utility and your company. Another example of a list of electrical safety points. This presentation will be on the TESCO website, so if anyone would want to go there and pull this out for these graphics, feel free to do so. But once again, most importantly, use your own utilities rules and regulations, because they will vary from company to company. And the slide just repeats that sentiment. So, when approaching a meter installation, always approach an electrical service with caution and while wearing your full PPE. Why? Because that's your first line defense if anything should happen. Never stand directly in front of the meter when removing the meter. Before you even open the box or get the cover off, look for a live box, bees or other live animals, broken seal showing that possible tampering, the cover dropping off, the entire box unattached from the mount or the building, storm damage, missing knockouts, cracked or broken conduit going to the meter installation and meter box, loose connections of the meter base, meter pulling away from the wall, or inadequate fastening of the meter base and or mast to the building. And always be ready for surprises as you pull the cover off the meter base. As you see here, we've added this for a little shock value, but things like this can happen. We see our little friend here that was attracted to the warmth of the meter base and subsequently got himself barbecued in the meantime. So always look for animals, big and small. They can pose a significant safety concern, as this slide shows. Here's another slide, and as we zoom in, we can see, and this was actually taken down in Oklahoma, we can see this little guy waiting for visitors inside this meter installation. You'd be surprised how big of a animal can make its way into the meter enclosure. So once the box is open, issues to look for: an open line side connection to the meter socket, a missing neutral connection to the center lug in the meter socket, cross wiring between the test block and the meter socket, hidden jumpers, line to load, diversion situations on both legs, a dead short, phase to ground on the load side of one leg of the socket, partial short, phase to ground on the load side of one leg of the socket. Any mechanical breakdowns of components, overheating, corrosion, excessive moisture, contaminants. Look for frequent jowl changeouts resulting in low jowl tension. We touched base on that in the previous slides. We're going to get to more detailed on detailed information on how loose jowl tension can lead to hot sockets here in a few slides. Excessive electrical load, overload or short circuit. Look for loose or melted conductors, ground settling, stretched frost loop, and signs of previous arc flashes. Corrosion levels on components again. All things to look for once the meter enclosure cover is removed. Continuing, backfeed meter socket, the backfed meter socket, such as a generator in use, ground fault, phase-to-phase fault, and pulling a meter jaw with the meter. This is actually occurs a lot more than folks realize and want, but as you pull the meter, a meter jaw can come out with it, especially if it's fused together through a hot socket condition or broken in some way. So I want to go into detail about hot sockets. This has been a big topic in the recent years. I've done presentations on hot sockets in and of themselves at various conferences because it is such a large issue nowadays. And it's one of the primary things to look for as far as safety concerns in the field. Hot sockets are by no means new to the industry. They've been around for decades. However, in recent years, because of the AMI deployments, they've become more and more common and under the microscope. And so years ago, in a joint project with Landis and Gear asked TESCO to get to the source of hot sockets and the root causes, because at the time, meter manufacturers were pointing the finger at the socket manufacturers, and the socket manufacturers pointing fingers at the meter manufacturers. And so TESCO took on this project, and it was real easy for us to start this endeavor because we had a lot of old meters in our warehouse that we could easily segregate and inspect for hot socket conditions, pitted, discolored meter blades, melted back planes, and we were able to pull those out and segregate them for further evaluation. We also reached out to the local electrical contractors in the Philadelphia area where our factory's at, where these guys would typically go out, and if they pulled an old meter base, they would typically junk it out for scrap prices. We offered a little bit more than scrap prices for them to bring in the old meter bases so we could evaluate meter sockets, meter bases, and installations from multiple manufacturers in multiple time frames throughout the decades, and be able to look for signs of hot sockets in those meter bases. From there, we put together a big list of possible root causes and created this fixture here, test fixture, which enabled us, one of the big possible root causes that we wanted to evaluate was vibration in loose jaws. And so we created this fixture here, which vibrates meter jaws up to 3,000 cycles per minute. It's got high-speed cameras, video, temperature sensors, and with this unit, we could recreate hot socket conditions up to and including flames if we just had a couple conditions present. First of all, we needed current, even surprisingly even low current under an amp. For a form or source of vibration, this could be anything from an installation close to train tracks, fork truck traffic, or even a highway, but a source of vibration, and the insertion force on the jaws of less than 10 pounds. Over 10 pounds, we could not recreate a hot socket condition, but under 10 pounds, we could consistently recreate a hot socket condition. The graph that I'm showing now shows just how quickly, when you have those conditions, a hot socket can rise in temperature. So it doesn't take much time at all to get into dangerous temperatures, and which will result in, of course, the symptoms, the discoloration, the melted meter, and potential fire hazard. So from there, what we did was, because of all the finger pointing between the meter manufacturers and the socket manufacturers, we obtained brand new out-of-the-box sockets from all the different socket manufacturers. We tested the insertion force of those jaws, and we saw out-of-the-box 60, 70, even 100 pounds of insertion force. Very good design and quality out of the box across the board. So at this point, we knew that the finger pointing was not warranted. It was not the meter's fault of causing the hot socket conditions, and it wasn't the socket manufacturers. However, we noted as you insert a meter into the jaw and then pull it out, the insertion force drops. If you reinsert and pull it out again, it will drop again, and in as little as 6 to 8 iterations, you can get under the 10-pound threshold and have the conditions necessary for a hot socket to happen. Basically, what happens in a hot socket condition is the lack of jaw tension allows for micro gaps shown here. They can be very small, like 1/10 of an inch. And with the vibration, it causes micro arcing, which pits the plating, and then it's just a domino effect and increased temperatures from there. And so hot sockets are a critical issue in our industry now. The new solid state meters cannot handle the high temperatures as the old electromechanicals did. So this is a key point to look at when out at the meter installation. This graph shows just how quickly and the number of iterations it takes to get under the thresholds of the 10-pound threshold where you're in a dangerous level for hot socket conditions. Any questions on safety issues and hot sockets at a meter installation? Okay. Now we will switch gears to billing issues. Any mistake in any part of the service can cause a billing issue. Miswired VTs can cause it. Miswired CTs. If you forget to unshunt a CT before leaving a meter installation, you've effectively cut off a phase of the meter registration. We have seen CTs with the wrong labels on them. A 400 to 5 labeled as a 200 to 5 or vice versa. Also, CTs can get magnetized, which will result in incorrect billing and registration of the energy by the meter. Any issues with the secondary and meter installation wiring, reverse CT secondaries, cross CTs, miswired test switch, a test switch left over can all affect your revenue and the registration of the meter. The meter itself, having a wrong meter or an incorrect multiplier. Now, I want to go over the incorrect multiplier because in numerous cases we've seen issues in this area. As we know from the previous session, the CTs and PTs scale down the customer load to a level that the meter can effectively, accurately, and safely measure. But it's only going to measure a fraction of the energy used by the customer. So through the use of a multiplier, you then upscale and calculate from what the meter reads back to what the customer actually used. It's the difference between the meter reading and the actual usage. So in this example, say if you have a 480 to 120 PTs that would give you a scaling factor or a multiplier of times 4. Say, for instance, your CTs are 400 to 5. That would give you a multiplier of 80. Multiplying those two values out, the overall multiplier to apply to this meter service would be 320. And that's what you would actually bill from. Any questions on incorrect multipliers? Okay. Shifting gears here, there are a lot of tools at your disposal to keep you safe and help you at the meter installation. That will, first and foremost, your simple handheld meter allows you to measure, do socket checks, make sure you have the correct voltages and currents where they need to be and not where they shouldn't be. Meter pullers are available to help isolate you from any dangerous voltage or currents around the meter as you pull it. Temperature guns to measure remotely relative temperatures before even opening the cabinet. And then hot socket gap tools shown here. Flashlights, headlights for additional lighting in dark areas. And if you do find loose jaws, repair kits available to exchange those out in the field and bring the meter installation back to a safe situation. So just a small handful of the number of tools out there that can help keep you safe while performing your job at the meter site. I've included some references here. This presentation will be on the TESCO website for further review. So if you want to look more in depth at any particular item we've talked about here, feel free to find this session on our website. And also feel free, if you have any questions, to give me a call. I got my contact information here. Any questions at this point on anything that we've talked about in the last couple hours? Sounds like everybody's quiet again, I guess.
You must have done too good a job, Rob.
So anything? Okay, I guess we're going to wrap this one up a little early then.
Appreciate it, Rob. Thanks a lot.
No problem. If anybody does have any questions, concerns, comments, after they sleep on this information, feel free to give me a buzz and I'll get you taken care of. Thank you much.
Thanks, Rob. Thanks, everyone, for joining. We'll see you tomorrow morning.
Thank you.
Take care, everyone. Bye-bye.